Hey, hi folks. So today we have Charles, one of the co-founders of Letta, and he is also one of the original authors of MemGPT paper. I'm pretty sure a lot of you would have read it and at least heard about it, about the repo. It got pretty viral last year. Charles, welcome to the podcast, the AI Agent podcast. Would love for you to describe what you're doing at Letta and how like you started your journey with MemGPT and kind of that evolved into a company that you are building, right?
Yeah, so we started working on MemGPT. So I think the paper came out like about a year ago. We were working on some kind of like early prototypes of these sorts of like self-editing memory chatbots. Maybe around in the summer of last year. So yeah, I mean, we really got started with MemGPT and the ideas behind MemGPT just from playing around with chatbots. So basically, at the time, like GPT-4 with function calling had just come out. I think GPT-4 had come out, and I think I was pretty excited by GPT-4 and kind of the reasoning capabilities of GPT-4. Especially kind of the big jump that happened on top of GPT 3.5. But I think, if you played around with GPT-4 at the time, it was 4K tokens of input on the API. And they spent like 1,000 tokens customizing the agent or customizing GPT-4 to try to act like a different persona. Spend another 1,000 tokens to give some input about kind of the user so that it has a bit more like customized experience. And then you're only at like 2K tokens, and it's only a few dozen messages before you run out of space. So I think the immediate like first reaction I have is that like QB4 is pretty amazing. But it basically, yeah, it you only the magic lasts for as long as like the context window lasts or like before it fills up, and that's not for much time at all. So like if you actually like plugged in GPT-4 or a chatbot using the GPT-4 API into some sort of like Discord or like some natural messaging interface, you basically like the experience would be pretty lame compared to what you might expect like the model could do. So I think like where we really started playing around with MemGPT was when the function calling API came out. And I think like one of the first things I thought of when I saw the function calling API was that, well, what if you kind of use tool calling to self-edit your own memory, right? So like if a new fact is learned or something, why don't you just like allow the agent to call a tool to edit the system prompt? And you can kind of start reserving areas of the system prompt specifically to be long-term memory. And you can do things now where you like have the system prompt itself is formatted from structured data and tools are editing the system prompt. But just the general idea of like giving an LLM control of its own memory. And then also, making the LLM kind of like self-aware that it has a limited context window. So kind of explaining the problem to the LLM and letting the LLM decide how to handle it. Yeah, that was really like the start of MemGPT. And in terms of like how it expanded into kind of led of the company, I think like very early on, we released MemGPT as like a research prototype. And I think a lot of people like immediately, I think part of why it went viral is because people really got the idea. They're like, oh yeah, I play with LMs, but I also kind of feel like I understand this problem. They don't really have long-term memory. They only remember what you put into the context window. And this is like a very intuitive way to like give LMs long-term memory. And I think actually like one immediate consequence of that is that you can build much more interesting applications if your LLMs have long-term. You can now start to build applications where, you have like a one-to-one, like long-term relationship with an assistant or a companion. And you just couldn't do that before in a meaningful way without long-term memory. So I think we had the research prototype and then like very shortly after that, they were inspired by the research prototype and actually started trying to like use the code. And you're seeing like forks up MemGPT. There's like MemGPT plus Fast API or MemGPT plus Flask. And this is how you get a power like a chatbot with MemGPT. And the code was like very much, it was a research prototype. None of the state was actually written to a database. It was written to flat files. So I think very quickly we kind of like realized, the demand for this sort of an agents framework that's focused around like statefulness and long-term memory. So we really pivoted quite quickly into making a project about like a real full-fledged like framework. And in the past few months, it's really been focused on engineering it correctly so that you can actually like build applications on top of it. And that's really a lot of what we've been doing with Letta is kind of taking a lot of the abstractions from the paper and like kind of putting them into practice in a way that where you can build really cool stuff.
That sounds like quite a bit of a story. And coming to the architecture, right? I was very intrigued by the whole kind of analogy of memory management in LLM and memory management in OS. So, what was the key genesis of that architectural choice? What were some of the challenges that you faced? What were kind of the differences from like traditional deterministic OS management versus probably some sort of emergent ability of LLM to kind of manage the memory? Like, if you can go a bit deeper.
Yeah, I think, you know, the research lab I was a part of at Berkeley, well, I was part of like both the AI lab and also the AI systems lab. But particularly at the near the end of my PhD, I spent a lot of time at the AI systems lab. And yeah, naturally, if you're in a systems lab, there's a lot of this is the same kind of building that the OS people are the real OS people are gonna be working out of. So there's kind of a natural inclination to borrow more systems level analogies. But I think like the OS analogy is pretty interesting. I think at the time that the MemGPT paper came out, we are also just very interested in using the OS analogy because there's a lot of other like chatter around this idea as well. So I think like Carpathy also had some tweets around the LMOS, and I think like I think LMOS can mean a lot of different things, and I think we had a very particular idea of like what it really should mean. So I think in the Carpathy version, it's kind of like you have the LM in some sort of it is as part of a bigger computer, and it's kind of like a computer where the LM now has access to peripherals. So kind of like Composio or something, right? It's kind of LMs using tools. And I think for us, we really thought actually LMOS, it makes more sense for it to be talking about the token management. Because think of, LMs actually is a pretty good analogy. I think in many ways it's just kind of like stateless chips or something is a stateless computation where, you're feeding all the inputs, it runs one execution step, it has outputs. But apart from that, there's not like any state that's maintained in the system other than what you're maintaining yourself as like a system orchestrator. So I think there's a pretty interesting analogy just like to memory management on top of kind of like compute units like CPUs or GPUs. And yeah, so I think that it's a pretty good analogy for that reason. But I think maybe all analogies are only useful to a certain extent, and maybe the way in which this analogy really starts to break apart from how how memory or how memory management really works on like operating systems is I think with MemGPT, like if you think about the OS, the OS is the memory manager or the token manager or the context manager. I think those are all kind of synonymous. Then in MemGPT, we were proposing that an LLM itself is going to do the context management. So an LLM is making the decisions. It's not, some algorithm, some special queue. I mean, there's some components that are designed, but in many ways, the most important parts of the memory management are done itself by an LLM process. So you're kind of like instead of heuristics or algorithms, you're letting kind of it all be emergent from the desires or the properties of the LM. And I think it's, if you're building real systems, you're always going to have trade-offs on like what is learned and what is like programmed. I think for a research paper, it's much more interesting to kind of like have a very distilled idea. And in our case, we wanted to be like, well, what if this is memory management is just learned? I think it's interesting because I think it plays well with, like the bitter lesson. If at the time, I think it was LLMs were not they were significantly worse than they are now. So there would be like kind of mess ups where the LLM wouldn't move data around, wouldn't save memories correctly. But I think if you believe LLMs are going to get better and better, then you can kind of imagine that it's safe to like say the LM or some LM will play a very important role in managing the memory.
That sounds kind of like from traditional RAG-based system to more agentic system in some sense. I would love to know. I kind of remember like in the paper you had mentioned like a lot of emergent ability of kind of very similar to human how LLM is managing the memory around updating the statuses of things, recent kind of recency bias or like putting the recent updates in the in the context more often, etc. Did you experiment with like the Claude 3.5 or 3.6 Sonnet and figured out some more emergent ability which probably didn't exist in the prior models?
Yeah. Well, I think certainly, there's been a lot of like a lot of people have used MemGPT. So there's definitely a lot of like, I would not be surprised if internal data sets at these companies like includes MemGPT traces. Basically like, and I mean like MemGPT specific and that like the system problem, like the messages are all formatted in like the MemGPT style. So I think naturally like the model is just going to get better and better the longer like a dominant workload like it's in their inference platform. But yeah, I mean, I think really the one interesting thing is just that, at the time, I think this kind of is related to the bitter lesson thing I was talking about before. But at the time we published the MemGPT paper, like the initial paper, it worked, but it like didn't work very reliably, and it really didn't work that well with any open model. But we kind of intentionally like made the decision to make all the outputs of the LM always function calling. And it was, I think at the time it was like a little bit of risky of a bet, but we kind of anticipated that just the models, they will just get better at function calling. We're just like trapped right now in a moment in time, but we can safely bet like it seems like function calling is picking up structured output or just like JSON mode structure. Yeah. So I think we kind of anticipated that would get better and better over time, and it did. And now you can really run like this MemGPT style LMOS with many, many models. So, but I think the better, yeah, I think maybe in terms of emergent properties that are somewhat interesting is just maybe I think the models are getting very good at having like internal monologue or like train of thought related to function calling, like interleaved in conversation. So I think that sort of data, like long multi-turn conversation where there was also function calling in the mix, I think that really didn't exist that much back when GPT-4 came out. And that I think that flavor of data is very much like kind of the canonical agentic data. Um, and yeah, I think now it really has been added to a lot of like the training data sets. So you just get a lot better stack traces. You like when you look at the chain of thought of the agent, it like looks very similar to what a human might be thinking as they kind of reply to someone or as they kind of like mentally jog their memory or update their memory.
Interesting. So, like, just kind of the deep, like diving a bit deeper into it. Do you think like it's kind of like what I generally consider humans also have a procedural memory, right? Where kind of people remember some like procedures that they do often. So is that something kind of coming out in the memory with these kind of agentic traces?
Yeah, so I think something like kind of remembering things that you do often, that is, yeah, if you think about like the design of like memory in a MemGPT style system, I think that's actually something that you might want to like have done or enforced via kind of heuristics, where basically have some sort of sidecar process that's tracking like how often like a memory comes up. And if it comes up a lot, then you kind of like want to inject it into like the pin memory section. Um, yeah, I mean, I think one interesting thing that's kind of related that you see that I think was very surprising when we first saw it happen, like MemGPT is basically this first happened like I'm talking about back, when GPT-4 first came out. Was if you kind of like if you allow the function execution to happen like very autonomously in an agentic loop, and then you propagate the errors back to the LM. If the error is like relatively clean, the LM actually can be pretty adept at like solving the problem. I mean, I think that's what you see with kind of like all the sweet kit examples. So I don't think it's that surprising anymore. I think at the time it was kind of surprising that an LM could kind of correct its function calling. I think another thing that's like pretty cool is if the LM also is aware that it has like persistent memory. I think we've definitely noticed examples when playing around with MemGPT and Letta where the agents, like we actually as users or as developers, we actually made a mistake and we like wrote the system prompt incorrectly or we like gave bad instructions. And the LM will kind of like it'll try to execute a tool in a certain way and it fails. And then it tries again. And you can like kind of track the internal monologue and you realize that it at some point realizes, hey, I think the instructions were bad. So I'm going to go and like edit the instructions or I'm going to write a note to myself that like actually, I should ignore the instructions the human gave because they're wrong and I should do this instead. So I think that's kind of like, maybe in this same flavor of like emergent behavior that someone.
I think we should try running the secret with Letta and Composer's tools. I think that will be very interesting how kind of that plays out. So diving deeper into like kind of now because you're building into Letta, like what are some of the challenges that you are facing with for example, now it's like much more scale, right? I'm guessing with your kind of user base, etc. So what are some of the challenges that probably you didn't anticipate you'll run into? It can be like general system challenges or kind of technical changes that you might have to build into the framework. Is there any?
Yeah, I think there's a few that come to mind. I think from a technical perspective, like one of the biggest challenges in building a framework like Letta, um, Well, I think firstly to kind of like set the stage, like Letta is very different from a lot of other agent frameworks in that it's a service. So it basically there's like state that's persisted over time. Like a lot of other LM frameworks or agent frameworks, they're SDKs, right? So they don't not actually like really track state. They kind of just provide like interfaces that help you use kind of like chat completion scope, right? In a more agentic way. Letta is like very focused on, if you're going to use Letta and create agents with Letta, those agents like persist forever in disk on a database. So I think there's fundamentally we're like building when you build a service, there's just a lot more moving parts involved in making things work. It's like much harder to like write database code than it is to write code that like opens and closes file files. I think the other part is that like Letta from the very beginning has had a very strong focus on being model agnostic. And what being model agnostic means if you're storing data, if you're kind of like storing all the events, all the messages of an agent, is that you need to store that data in a way that is itself model agnostic. So you kind of have to determine some sort of intermediate representation that you're going to store like messages in a way that you hopefully, when the new models come out or like a new revision of the model comes out, or a new provider emerges, like, a new competitor or Anthropic and Cohere comes out and they have a slightly different API. You kind of want to future proof your data in a way where you anticipate that you can remap it to the other provider. So I think in practice, that sounds maybe not super hard, but in practice, it actually is quite complicated. I think it really gets complicated when you start to think about multimodal. Because multimodal is just like all over the place right now in terms of kind of like the support, the performance, kind of the way API providers expect multimodal data to be parsed. And then obviously, it seems like now we are also moving towards a world, maybe not extremely quickly, but in the next few years, where a lot of the base models are going to be kind of like audio native, so kind of speech to speech. So you really have to think about what the APIs look like at that point. So yeah, I think those are like kind of the biggest infrastructure challenges that exist. Obviously, there's a lot of stuff around agents and just like getting agents to work well. So I think it's like two sides of the coin, but on the infra side, those are like the two.
Like like you kind of face some kind of trade-offs between retrieval accuracy and latency. Like, I mean, how do you handle that? Like, like that we are dealing with chatbots. I think most of the times we want like somewhat instantaneous like answers, right? But like with kind of memory, like, and we all have faced like memory issues and kind of a laptop where kind of laptop itself kind of acts very weirdly when there's like swap and all involved. So how does that work out with Letter?
Yeah, I think, yeah, I mean, I think in terms of like yeah, I'm trying to think of a good example. Basically, yeah, I think in terms of like just things like working or not working well, uh, or like, so I think, okay, but maybe a very good example is basically like a lot of users who use Letta, or developers that use Letta, they basically have certain constraints that are derived from like their end user application. So let's say they're doing something like kind of like a character AI clone, right? So like what if they're doing a character AI clone and it's text only? Well, if it's text only, then there probably are less considerations on time to first token latency than if it's involves speech as like the native modality. If someone is integrating some sort of, if their end user product is like the primary mode of using it is through speech, I think time to first token latency is really important. And one thing that Letta does on the topic of kind of like a canonical data format for every model, I think another thing we bet on very early is that it's going to be very common or like ubiquitous to always have chain of thought. As tokens kind of become cheaper and cheaper, and it just seems natural that like everything you just have a lot more chain of thought than not chain of thought. So in Letta, every single like agent is always generating a chain of thought. So this latency problem is actually like not time to first token, it's time to first spoken token or time to first like non-chain of thought token. Um, so if you want to actually like build, a system that is doing this memory management, also is doing chain of thought, but then also has like really low time to a minimal time to first token, spoken token latency, then you really have to start thinking about like, okay, well, I think we probably need to offload. We either need to use a really fast inference provider or we need to offload the memory management to like a parallel thread. So I think that's kind of like the most obvious example where you start to run into kind of collision with like the design of the system and the constraints of the users.
So what do you mean by exactly like kind of, but it's a single kind of LLM context, right? So like how like can you go into detail around like separating the memory management itself to the another thread? Because I was assuming that will be handled by the LLMs.
Yeah. So one thing that's kind of different from MemGPT and Letta is that we like with Letta, I think we are trying to make it kind of a distinguishment between what is the general concept of like LMOS for memory management or context management, and then what is like the specific reference design that was in the paper. So I think like the specific reference design in the paper, we call that kind of like the MemGPT design or the MemGPT agent. And in that agent, it's one thread, one LM, both does conversation, both does like function calling, and it also does the memory management. But in Letta, we actually like support generic agents under this like LMOS framework. So you can actually create like we have in the repo, I believe in an open fork, it just hasn't been merged in yet as a feature, but there is an agent that has like a split thread memory where basically the primary agent that does conversation, that is the main kind of like blocking process when you run kind of the inference step or you do the post request. The blocking request is, or the request is blocked by that conversational agent. But that conversational agent actually is not responsible for managing memory. A separate agent that runs in parallel that has a very similar prompt, but it's like a little bit, it's compiled slightly differently. That agent will run in parallel and kind of like do memory management on the side. So then if you have this system where you're piping back out to a text to speech system, then you would only pipe back out kind of like the reply from the conversational agent. And the memory management agent will kind of be something that you can observe, but you don't, it's not like blocking the text to speech.
Coming to kind of you mentioned like character.ai type use cases. So would love to know what type of use cases and applications Letta is kind of being used for, and what are some of the idiosyncrasies across all of them.
Yeah, I think so. What we're trying to build with Letta is effectively like a new version of an AI API, and I think it's like the kind of the design, general design of like what the AI APIs of the future will be, which is like not chat completions APIs. It will be like agentic stateful APIs. So at like face value, it's a very horizontal proposition. It basically, in the same way that chat completions APIs, they don't necessarily, it's not every single person using chat completion API is using chat or building chat applications. There's a lot of people who are building like autonomous workflows or classification tasks, recommender systems with chat completion APIs. So I think we envision it will be very similar for like the next generation of APIs. Basically, you'll have, people building things that look very much like agents, the way we think about them today, like web agents, things like that. But there'll also be people who are just like building with AI on those APIs, even if it doesn't look like an agent. If this is the most natural way to interface as opposed to a chat completion API. But that being said, I think like in the immediate present, they're like very like if you think about what does an API like that give you, other than it being like much better DevX, what does it actually like immediately give you in terms of features? I think one thing it immediately gives you is it allows you to offload the memory management to the server. It allows you to offload kind of like the agentic leaping to the server. It allows you to offload the execution of tools to the server. So it's dramatically simpler way to program with AI. And I think like some of those benefits really shine today in applications. If you think about like the widest, distribution of AI applications that kind of center around chat. And a lot of chat applications really actually do benefit from long-term memory or like memory that is like self-editing, persisted. So things like, yeah, the character AI settings, like very obvious one where like character AI as a product would be much better if like the chats were had like long-term memory in them. I think it's just kind of a technological limitation that like character AI doesn't ship that kind of feature. They would love to, I'm sure, but they just haven't found a way to make it really work at a quality threshold where they're kind of comfortable shipping it. But I think there's just like a lot of other chat related applications, basically like, um, his like healthcare, education, these are all like obvious examples where you have a lot of individualized data that you want to put into the context window in a way that you want it to be observable. It's kind of like a memory. And you also want these things to learn over time, like a educational tutor to learn the habits of the student that they're tutoring and to like kind of better their tutoring, right? And similar for like a healthcare page or healthcare advocate or something. It's going to kind of learn over time if the patient expresses new opinions, new symptoms, it should kind of self-edit its own memory. Even things that are just kind of like workflow, more workflow style, kind of like AI SDR, AI DER. Um, those also really benefit from being in kind of like this long-term agentic loop, right? Because then you can provide the AI SDR or AI BDR like feedback, right? If it like does a bad job, you don't have to go back and edit the prompt yourself and like retry. You can just like give it verbal feedback and watch it edit its own prompt. Right? So I think really kind of like what we're seeing Letta most used for today is really just driven by like what people are using AI for today, which kind of is like really chat dominated. But I think it just will naturally like go with the overall kind of like, usage patterns, right? So I think things will just start to look more and more agentic as we go to the future, and I think we anticipate kind of our workloads. So
And kind of continuing in that trend, so where do you think like there are in some sense I can see three parallel domains, right? Like one is kind of RAG, where mostly it's like factual information. Then the other one, like long context windows, like for example, Gemini 1.5, and then like Letta with memory. So like for kind of general users, how do you differentiate the use cases for all three and each one of them work with?
yeah, I mean, um, I think like philosophically, the real comparison is kind of just between like Letta and RAG. So I think long context, it's really kind of a matter of if we go back to like the OS analogy or like to the computer analogy, if like if the OS, if the Letta is the OS and the chip or the computer inside the OS that's being or that's being run, the hardware is an LM. I think basically longer context windows just means like better hardware. You're like alleviating bottlenecks. You can just like do more with the hardware and worry less about, for example, having to shuffle memory back and forth because now you can be you just have more optionality. You have more choices on how you want to do things. I will say, like with long context, it's very nice to have long context models. But I think, in practice, often people they don't really pack the context window all the way to 200K because it's like a huge latency and cost. Huge latency, huge cost. Also, often the performance is not better than if you were to do a lot of work upfront to summarize down and then run, like summarize down with cheaper models and then run like this, or a high level inference with like a stronger model. And then, I think between like RAG and Letta, again, I think the distinction is really that I think like Letta, it's about at a very high level, just what is the memory management system? What is the context management system? And I think RAG is like one way you can do context management. It's like a very simple way to do context management where you have you have basically a heuristic, which is I have chunk data somewhere that also has been pre-chunked, pre-embedded. And now my heuristic is I'm going to like take the last sent message in the chat, send it off to like some matching score, and then pull in the top K chunks, right? I think that's like one mechanism for doing memory management. So you can kind of think about like Letta, you can do RAG in Letta because it's one form of memory management, right? But I think there's many more powerful forms of memory management than RAG. I think RAG, maybe a lot of people, I think when they say RAG, it's a very overloaded word and they're thinking broadly about like retrieval. So I think retrieval is like a much more interesting concept maybe because it just covers I think with Letta, if you think about what is the relationship between Letta and retrieval. So like what is the relationship between context management and retrieval? Well, context management is basically two things. It's the retrieval and then the generation of like the retrieval and then the editing of like the data that was retrieved. So it's kind of like the read and the write. So I think that's like a much more of a foundational relationship to Letta. It's like one side of like what context management is. Whereas RAG, I think, is a little bit more narrow. It's kind of like with one mechanism, one algorithm for doing retrieval, and you can have that as one tool in your toolbox for memory management. But I definitely don't think it's kind of like the ultimate tool, and I think it will be like kind of phased out very quickly as time.
That makes sense. I think like so how you are kind of thinking about it is like RAG is probably like when LLMs were not that great in like the function calling ability, is it kind of right to say that that was like somewhat of a shortcut to give value in that case?
Yeah, and that's a good way to put it. Yeah, I think it's kind of a shortcut, like a very easy way. It's easy both like from an intuitive way to understand it, and then also it's easy to implement. I think those two things made it very popular. And I think it like works well enough in many cases, right? I think the immediate problem with RAG is just again, I'm not about like RAG necessarily the scientific paper. I'm just talking about like RAG in terms of like the median way people are using the term today, which is mean like top K cosine similarity, like chunking. Um, I think that idea is just it's not. I think even the results are just nowhere near as good as they could be if you just replaced, the embedding search with some other like more intelligent search. I mean, we've had like indexing and databases for a very long time. And I think well, when it's just text, you can often get better results through like a different retrieval method than kind of this cosine similarity on chunks. So yeah, I think it really became popular because it's like there was a very desperate need to like combine you enrich LMs with like real data to make them actually useful for real tasks. And RAG, in the way that most people use it, is a very quick way to do that, and it's very quick, very intuitive, and it gets solid results.
Makes sense. Makes sense. So what are some of the interesting areas and kind of developments that you are most excited about in particularly in agents, in memory management, etc. Which some of that like Neta might be kind of heading on, and some of the other things around.
Yeah, I think I'm very excited by kind of the continued progression in LM tool usability. I think yeah, right now, you know, It a year ago when we first, like, released MemGPT, as I already said, like, the open models were just not very good at tool use, and we basically had to say in the paper, "Hey, this really only works with, like, GPT-4." That's, like, 100% not the case today. I think, like, the even with, like, the last generation of llama models, you could already, like, do a lot of stuff with Letta. Um, so, yeah, I think there are still limitations today, and I think the most obvious limitation is basically, that the tools need to be kinda simple, and they need to be, like, dumbed down. I think we'll be able to get like more lazy with how we present tools to LLMs as they get better and better with tools. In the same way that as like we get more and more RAM on our laptops, like developers become more and more lazy about like how they use it. But I think also like tool calling itself is like it's very unsolved. Like you have basically the chat completions API tells you, please do not include more than like 10 tools, right? And that's because they have like benchmark internally and they're like, okay, kind of performance falls off a cliff if you include more than 10 tools. Um, but at the same time, I think there's a lot of like really, even if like the base models are not very good at using more than 10 tools, there's so much you can do just with that base model, like in terms of like building a system around it to make it better at tool use, right? You can do like tool RAG, you can kind of like some sort of tree search on tools and then use that to like feed into structured or like constrained decoding, right? So I think I'm very excited about basically like the LLMs getting better at tool calling, and then I'm also very excited about just the systems around the LLMs getting better and better. So I mean, at Letta, that's really what we're focused on. We're building like systems around the LM or the LMOS, whatever you want to call it. But I think both on our end, it will, we'll get better quickly, pretty quickly. And I think like the community is also building other stuff that will get better very quickly. That will just make agents a lot better than they are right
So yeah, the we are doing more on the tool side, improving the tools for the game. But yeah, I totally agree. What are some of the kind of next set of features and exciting things that are coming up, like that the users can be excited about?
Yeah, I think the number one thing we're very excited about is releasing this, what we're calling like the Letta ADE. So it basically is kind of, if you think about, the LM playground, I think it's, LM playgrounds are incredibly popular. Like every single LM provider or like frontier model provider exposes some sort of a playground. I think it's very intuitive. It makes a lot of sense why people like to kind of iterate in a playground. But we don't have that for agents. And I think it's for various reasons. I think agents are kind of like ill-defined. But I think also there is no like hosted platform for agents that's very good. Like OpenAI has kind of the assistance API, but it's not popular for various reasons. Um, and I think their version of like their assistants, their agents playground is just kind of like the same thing as LM playground, but for assistants. I don't think it's like super interesting. Um, and yeah, I think we basically are very excited about what you can do if you really kind of like reimagine what the playground is for agents. So yeah, we're really excited to kind of like take that private beta and kind of like GA and let people play around with it. I think the other thing that we're really excited to do is kind of like release our cloud platform, which is like kind of serverless agents, hosted agents, whatever you want to call it, like turnkey. And I think Yeah, I think one thing we hear like so frequently from developers is basically again with this idea about like why the API is today not good enough. Like if you're a developer today and you kind of want to like deploy, let's take the character AI example. That you want to deploy like a character AI style app, like it's actually really really complex. Like if you want like, it's not complex. It's hard enough for developers to have to, like, build out the product, but then they also have to, like, now think about, like, am I doing recursive summarization for my chat history? Like, how am I going to manage if I, like, get I have to switch for OpenAI and Anthropic? What if I wanna eventually go to there's so much they have to do, and I think, like, in building kinda like the Letta both the Letta open source, and then also, like, the Letta cloud platform, like, one of the biggest advantages of using something like that is, like, you as a developer, you can just focus on the product. You don't have to think anymore or I mean, you still have to think about like kind of the way you want to design the AI system, but you don't have to think about like standing up the infrastructure, writing all this code for memory management, writing all this code for like function calling. It all just like kind of comes bundled together. And I think that just doesn't really exist on the market today. So I'm really excited to kind of release that and give it a develop.
Of them sounds really, really interesting. I think we are kind of collaborating on some of that front as well. So I'm really looking forward to that. Uh, yeah, kind of coming almost to the end of the podcast, I generally ask a surprise question to my guest, which is like, so things are changing very, very quickly, right? I mean, like last 2 years have been kind of, it feels like the progress that has been made in the last 2 years, it kind of is more than probably last kind of 10 years before that. What are kind of some of the things that you're really excited about, and what are some of the predictions for next 5 years? Like how the world will be changing in the next coming 5 years?
Yeah, I mean, I think the sorts of prediction things are always pretty hard. So much changes so quickly. And then some things like, change a lot slower than we expect. So I think in terms of like from the LM side, I think I think kind of Dario from Anthropic has kind of like postured about like if you like whether or not the scaling laws will like continue, and he's kind of like hedging. I forgot exactly. It was like maybe 2080 or in his own blog post. Um, yeah, so I think basically like we will probably see like whether or not the outcome will be resolved in like 5 years time, right? So I think either we will have like we'll have some new breakout in terms of like the way synthetic data is generated and the model, and we'll start to get like, we'll have another 3.5 to 4 bump in model performance or like in the pure reasoning ability of like the base token to token LM, or maybe like a new architecture comes out or something. So I think that could happen. I think also there's the flip side to that is basically like we start to kind of saturate what's going on with like the base token to token LM model. And I think maybe, from my perspective, I would guess that's more likely to happen. So if I'm making a bet on the 5-year future, I think that probably will be kind of the outcome. But I also think that like agents will continue to get like incredibly good. We will just see like year over year improvement on agents, and I think it's really because a lot of like what makes agents and like much better than chatbots, or they do things that chatbots can't do is because of all like the systems you have to build around them. Right? I think some people, at the very beginning, there's a lot of chatter around like prompt engineering, or if we're gonna have like prompt engineers, or like basically, oh, the scaffolding is just like cheap and it's all going to get bundled into like the model provider. I just don't think that's going to happen. I think basically what you're going to see instead is like the what we used to like kind of call like the simple prompt engineering or scaffolding or whatever is going to start to become very well engineered, because I think if like the base primitive of what you're programming on top of kind of stabilizes a bit, like maybe you still have year over year improvements, like you still like chips get better and better. But we know what we're working with now. We know the limitations of the base models. We know kind of like how to wrangle them, like what their issues are, how to make them less stochastic, more stochastic, whatever. Then I think like it's really off to the races in terms of the engineering on top of that. I think then you start to have like very principled design patterns emerge, very good engineering at the layer. That's kind of basically what Letta is doing, this like token management, context management. So my prediction would probably be when the agents get very good in, 5 years. I think there's a lot of hype, and I think I mean, for certain verticals, I think it's kind of like it's maybe overblown, but I think just overall, there'll be a lot of people that don't use AI today that will be using AI in 5 years. Like tons of people on the planet will be using AI, and they'll be using AI that's like powered by agents APIs. They won't be using AI that's powered by. So yeah, that's kind of my general wager for 5 years.
That sounds like a future, I guess. Very interesting. Like I think the last question, I think a lot of kind of AI agent builders and AI agent developers will be kind of watching this episode. So, any advice that you have for them?
Yeah, I mean, I think maybe one bit of advice I get is, if it's possible to build like an open source, I think that's always, especially when you're early, it's a great thing to do just because it's really it's a way to really get quick validation on your idea. I think there's a lot of people that are like looking at open source projects. I think it's a little bit like calmer than it was, a year ago. I think, but there's still a lot of people that kind of like surf GitHub or like are very excited to try new AI projects, and that just like won't be the case, indefinitely. So I think while there's still like so much interest in open source AI, it's really great to kind of like get feedback from like this community that's pretty big. So yeah, that's gonna be like my main piece of advice is just like if you can kind of build on the open. And then yeah, I'd say my other piece of advice is to kind of I think this is loosely related to like some stuff that like Sam is constantly saying about like how build. I think his version of it is kind of like, we're gonna destroy you if you don't build or if you don't build vertical. But I, I do think it is like reasonable advice that if you are building or just to think about like where LM models will be in like 6 months or like have some thesis about it. You could have a thesis that like the LM models will be just as it won't be any better. It'll be the same. But like have some thesis about it and then really think about like how it's going to change what you're building because I think it's not a great to like sink like a ton of work into a project that's like very a point in time. You kind of want to be building for the future.
That sounds like a pretty good advice for people building LLMs. Awesome. Thanks, Charles, for kind of coming on board and kind of a great episode. A lot of insight.
But so yeah, thanks so much for having me. Yeah, it's been a pleasure to work with you at Composio. I'm very excited for our upcoming integration.
Thanks. Same here. I'm very excited about the upcoming announcement.